Hello viewers, in today's session we are going to discuss three important problems from derivatives, right? So let us start and let us first take this problem where we are given a function y that is equal to f of x square, and here we have f prime of x is equal to x times e raised to square root of x, and we have to find dy over dx. So here we'll make use of two important concepts. The first one is the method of substitution, and then we'll make use of the concept of chain rule, right? So let us here substitute t is equal to x square. So here we'll take t is equal to x square, so that this expression it can be written as y is equal to f of t, right? So now let us differentiate both sides with respect to x. So we have dy over dx, because here we need to find out dy over dx. So let us differentiate both sides with respect to x, and here we have d by dx of f of t, right? Now here we can make use of chain rule, since here we have f of t. So let us first differentiate f of t with respect to t. So we'll write d by dt of f of t, and then by chain rule we have to differentiate t with respect to x. Now d by dt of f of t can be written as f prime of t, the derivative of f of t with respect to t, and here we have dt over dx. Now to get the value of dt over dx, we'll differentiate here both sides with respect to x. So we have dt over dx is equal to d by dx of x square, and the derivative of x square with respect to x is 2x. So let us substitute dt over dx is equal to 2x over here. So we have f prime of t, and here we have 2x. Now let us find f prime of t with the help of this expression. Now f prime of x is defined as x times e raised to square root of x. So if we now replace x by t in this expression, then f prime of t is equal to t times e raised to square root of t. So here we can now write t times e raised to square root of t, and here we have 2x, right? So now we have already assumed that t is equal to x square. So let us resubstitute here t is equal to x square. So we have x square for t, and here we can also write x is equal to square root of t. So square root of t can be replaced by x due to this expression. So here we have simply e raised to x, and here we have 2x. So now multiplying x square and 2x, we have 2x cube, and here we have e raised to x. So the derivative of y with respect to x is given by this expression, that is 2x cube e raised to x. Now let us consider a second problem. So here we are given y is equal to f of x square plus 1, and f prime of x is equal to x square minus 1, and we have to find dy over dx. So again we'll make use of method of substitution and chain rule. So here let us take t is equal to x square plus 1. So now t is equal to x square plus 1. So let us differentiate t with respect to x. So dt over dx is given by d by dx of x square plus 1. So here the derivative of x square is 2x, and the derivative of 1 is 0, because this is a constant, so this is equal to 2x, right? Okay, so now let us take x square plus 1 is equal to 2 in this function. So we have now y is equal to f of t. Now let us differentiate both sides with respect to x. So we have dy over dx is equal to d by dx of f of t. Now again using chain rule, here we have f of t. So let us first differentiate f of t with respect to t. So we can now write d by dt of f of t, and then we have here dt over dx. Now d by dt of f of t is simply f prime of t, and here we have dt over dx. Now f prime of t can be obtained from this relation. So if we replace x by t in this expression, then f prime of t is equal to t square minus 1. So here we can write t square minus 1, and for dt over dx we can write 2x. Okay, so now here the value of t is equal to x square plus 1 due to our assumption. So let us substitute here t is equal to x square plus 1, and here we have square, and then we have minus 1, and here we have 2x. So let us simplify it, and applying the identity, that is a plus b square is equal to a square plus 2ab plus b square. So here we have x square whole square, then we have here 2 times x square times 1, then we have 1 square, and here we have minus 1, and here we have 2x. So this is now x raised to 4. 2 times 2 is 4, then 2x square, and here we have 1 square is equal to 1, and here we have 2x. So this is x raised to 4 plus 2x square, and here we have 2x. 1 and 1 get cancelled here, and now multiplying these two terms by 2x, we have 2 times x raised to 5, and here we have 4. 2 times 2 is 4, and here 2 plus 1 is 3. So the value of the derivative of y with respect to x is given by 2 times x raised to 5 plus 4 times x raised to 3. So now let us consider the third problem. Here we are given y is equal to f of x square minus f of 1 minus x square, and f prime of x is equal to e raised to x, and we have to find dy over dx. So again we'll make use of method of substitution and chain rule. So let us assume here t is equal to x square, right? So when t is equal to x square, let us differentiate t with respect to x. So dt over dx is d by dx of x square, that is equal to 2x. Now when we take t is equal to x square, then this expression can now be written as y is equal to f of t, and then we have here minus f of 1 minus t, right? Okay, now let us differentiate both sides with respect to x. So we have dy over dx is equal to d by dx of f of t, and then we have d by dx of f of 1 minus t. Now again, as we have done in the previous example, we can write d by dt of f of t, and then by chain rule we have dt over dx, and here we can now write d by dt of f of 1 minus t, and then we have here dt over dx. So now d by dt of f of t is simply f prime of t, and for dt over dx we can write here 2x, and then here the derivative of f of 1 minus t with respect to t can be written as f prime of 1 minus t, and then by chain rule we have to differentiate 1 minus t with respect to t, and here for dt over dx we can write 2x. So now this is 2x f prime of t, and here we have f prime of 1 minus t, and the derivative of 1 minus t with respect to t is 0 minus 1, and here we have 2x. So here the derivative of 1 is 0, and the derivative of t with respect to t is 1. So now we can write 2x f prime of t, and here this 0 minus 1 is minus 1, and when we multiply minus 1 with this negative, then it becomes positive, and here we have 2x and f prime of 1 minus t. So now dy over dx can be written as we can take 2x common. So here we have 2x, and then we have f prime of t plus f prime of 1 minus t. So this is 2x, and f prime of t can be obtained from this relation. So replacing x by t, f prime of t is equal to e raised to t. So here we have e raised to t, and then f prime of 1 minus t can also be obtained from this expression by replacing x by 1 minus t. So f prime of 1 minus t is equal to e raised to 1 minus t. So here we have e raised to 1 minus t. So now we have 2x, and here replacing this t by x square. So here we have x square, and then we have e raised to 1 minus x square. So this is the required expression for dy over dx.